If there is friction, means surface is rough, that is frictional force is present between the tire and the road, that static friction will provide centripetal force. That is one way of observing it. You see, we can minimize the use of frictional force by just banking the road. If we simply bank the road, banking means you raise the level of road outward. Road, you are going this way, turning, so this becomes circle of your circular path. Outer edge of the road is slightly elevated. This whole process is called banking of the road. Suppose this road has been elevated by angle theta. This becomes the slope of this road now. Three forces have been resolved. mg, n. These two forces have been made into three forces by just splitting it in two components, cos and sine. Now you just ignore this because it has been resolved into two forces. What remains is the two component and mg. That way, overall there are three forces. These balance each other. mg getting balanced by the component n cos theta. It's written here. So there is no vertical motion. They have balanced, they have counterbalanced each other. What remains is simply this one. And this is acting towards the center, will provide the centripetal force that might be written as the ratio of the two equations that will lead to the very common and peculiar result, that is tan theta equal to v square upon rg. From this equation you might say v equal to root rg tan theta. You should not remember that we already have one result. This is mu rg. R is radius of the circular path that we have followed for turning. Here in this case frictional force was considered, but now we are considering the banking of road, and we want to see how other forces, other than friction, how they can manage the requirement of centripetal force. So this becomes the maximum velocity on circular turning to avoid the overturning of the road, of the vehicle. Overturning of the vehicle, one has to maintain this velocity limit. So on the basis of friction we get this result. On the basis of this, without friction, without the consideration of friction, by banking of the road, this becomes the maximum possible velocity for safe turning. Now since we know that friction is everywhere, it is just impossible. Like vacuum is impossible, a smooth surface is also just impossible. Friction is always present everywhere. Here we'll also consider the effect of friction. Means you have banked the road, no doubt, but now we consider the frictional force also. By doing this, we get another result. Now, when you are turning the vehicle on banked road and frictional force is also considered, then we'll have to maintain the velocity within two limits. If we increase beyond a limit, it is likely to skid outward. And if we just make a velocity less than the required value or the optimum or threshold, whatever you say, less than that means it will have a tendency to slip down the plane, down the road towards center. And if we increase the velocity beyond a limit, then it will have a tendency to skid outward. Those two minimum and maximum velocities one will have to keep in mind. It's given here. This is the maximum velocity. This is ng tan theta plus mu 1 minus mu tan theta. And similarly here, this will be rg. rg tan theta plus mu, 1 minus mu tan theta, and likewise here minimum velocity is this one, maximum this one. Within this bracket one has to maintain the velocity in order to have the safe turning on a banked road that is supposed to be rough. And then what remains constant in uniform circular motion, speed, that is magnitude of velocity, kinetic energy. You might say the value of centripetal force, not as a whole. Three things are constant. What are the variables? The velocity. Because when you say velocity, direction is involved there and direction changes regularly. Centripetal force, though it is always towards the center, and value will be mv square upon r, that will be constant. But even then, we would say centripetal force as a whole is variable. Why? Because the direction is always changing. One time this will be due west, other time this will be due east, although it's always towards the center. So it is said that since direction of centripetal force is variable, as a whole this vector is variable. And one more thing, when we consider centripetal force, it's perpendicular to velocity. Work done is always zero. In any uniform circular motion, the work done by the centripetal force is always zero because it is always perpendicular to velocity. You might consider any example. If it is UCM, no work is being